Alrighty, guys. So here's the final two questions. Okay, so question 9. So we're trying to evaluate probability formulas and apply basic probability formulas. All right. So it says probability of x is zero point 0.6, probability of y is 0.7. What is the probability of x and x and y? All right, I'm so used to saying a and b. So x and y, when x and y are independent events. So you should remember that probability of x and y is just probability of x multiplied by probability of y. All right. So all I would do is just 0.6 times 0.7, which I think is 0.42. Oh, hold on, I might be wrong. I think it's 0.42 though. 0.6 times 0.7. Yep, 0.42. Okay. So very easy, very straightforward. Okay. So now it wants us to do probability of x and y, but in this case they're mutually exclusive of each other. All right. So if mutually exclusive means that one does not impact the other. So whenever something is mutually exclusive, that means the probability of x and y is equal to 0. All right. So this would be just 0. Okay. So then C, it says the probability of x and y is equal to 0.30. What's the probability of y given x? And are x and y independent or dependent? All right. So probability of y given x is equal to the probability of y and x divided by the probability of x. All right. But you should remember that, or rather, we were given the probability of x and y, not y and x. But you should remember that multiplication is commutative, so that means if I switch the order of things, I should get the same value. For example, 2 times 3 is the same as 3 times 2. So if I switch the order of them when it comes down to multiplication or and, all right, because and means I'm multiplying, that means that if I switch the order, I still will get the same result, okay? The only difference is that I'm not dividing by y, I'm dividing by x. So I would just use the 0.3 and then divide by the probability of x. Probability of x was 0.6, okay? So this would be 0.5, all right? So that's what the given would be, all right? So we need to now evaluate if it's independent or dependent, all right? So I'm going to run off into the next area again, okay? For it to be dependent, all right, probability of the given, okay, should be equivalent to the probability of their and, okay? Well, technically it should be y then x, technically, all right? So they need to be equivalent, okay? We saw that the given was 0.5 and the and, all right, was 0.42. Remember, this times is the same as this times this. They're the same thing, okay? So these are not equal to each other, so that means it's dependent, all right? So that means it's dependent, okay? So now final question, guys. Final question, question 10, all right? So question 10 gives us this table. It says we're trying to explore discrete random variables and tree diagrams. So a production company manufactures light bulbs, and the number of defective light bulbs produced on a given day can vary. The number of defective light bulbs in a batch of 100 is described by the following probability distribution. All right, where this number of light bulbs, and then this is the probability. Okay, that they are defective. All right. So essentially, it says what is the probability that the company produces at least 3 defective light bulbs? So at least 3 defective light bulbs means less than 3. So at least 3, no, at least 3 means 3 or more, sorry. All right. So I evaluate what's the probability for 3 or more. So 3 or more would have just been 1.5 plus 1.05 plus 0 or plus 0.05 plus 0.05, okay? I'm looking at 3 or more. So I'm looking at this area and above. So that would give me 20, and so 0.25, okay? So B, what's the probability that the company produces no more than 2 defective light bulbs? So no more than 2 means you're going from 0 all the way to 2, all right? You're just not going above 2. So essentially, when I'm doing this, all I have to do is just add up all the probabilities from 0 all the way to 2, which would have been 0.25 plus 0.30 plus 0.2, which would be, this would be 0.55, 0.75, okay? So, final one, all right? So it says, if the company produces 100 batches of light bulbs, what's the expected number of batches with more than 2 defective light bulbs? All right. So more than 2 defective light bulbs would be 3 or more. So that would be the same as this probability right here, 0.25. Okay. So I would evaluate the 0.25, but I need to know what's the expected number of batches. So essentially, I need to do n times p. All right. So in this case, the p is the 0.25 and the n would be 100. All right. So this would give me 25. And that would be the result. So again, just like